Hello everyone, and welcome to the first episode of our grand adventure through the history of mathematics. Today we are embarking on a journey that stretches back millennia to the very roots of counting and calculation. Have you ever wondered how mathematics began? It all started with a fundamental human need, keeping track of things. Imagine our early ancestors dividing spoils from a hunt or measuring the flow of rivers. The basic desire to quantify the world around them laid the foundation for mathematical thought. But how do we count in the beginning? Did we invent numbers or were they always there? What were the first symbols used for numbers? Well, you're going to learn all this and a lot more. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to the first episode of Genesis of Mathematics. Historians and scholars generally agree that our ability to count and our vocabulary of counting arose to meet practical needs and developed over many thousands of years. Numbers were originally expressed by reference to parts of the human body. For example, nose, eyes, ears, arms, hands, feet, and particularly fingers and toes in a specific order, so that making the numbers of these organs and members double as names of numbers. These number names were eventually simplified in their spoken forms long before the advent of writing, as the content and the concept of abstract numeration came into being. So here you can see that the diagram actually shows that the concept of using body parts which are representing the eyes, the ears and the arm generally began. And with the development of thought in the terms of genesis of calculation, the method that were used were basically counting the toes and the fingers, etc. So, and these forms were much before spoken terms, and then it underwent the simplification method. So here you see that the studies of primitive peoples, who live in isolation from civilization, or those who are hunting and gathering people, suggest several stages of development towards strict number systems. Now, hunting and gathering people are such as the Aborigines of Australia, Tasmania, Papua New Guinea generally have had or still might have specific names only for the numbers 1 and 2 and maybe sometimes 3. Yet, surprising fact is that they can count to as many as 6 by combining numbers. Let us see some of the examples. For example, 1 is generally 1, 2 is 2, 3 is 3, and then 2 and 1 will make up 3. Then 2, 2, 1, and this will make up 4, 5, and so on. So 2, 2, 2 will make up 6, 2, 2, 1 will make up 5, and 2, 2, 2 will make up 4. So in this way, if you talk of the Aborigines who calculated, so the initial fundamentals were only 1, 2, and 3. And then it added up and it developed into many. But peculiar to this is that in these languages, speakers refer to everything which is beyond 6 as many or much or plenty or less plenty, in the case as whatever it might be. So this is the way, if we trace back the genesis of calculation, hunting and gathering people, Aborigines, etc., fundamentally developed 1, 2, 3 and then they added up. But anything beyond 6, as it is written, is beyond is something which is much or plenty. Now you can see this kind of a similarity in case of our contemporary English. So when we count trees, for example, we refer to each tree counting 1, 2, 3, etc., 7, 8 until the tree cease to be important and we say a clump of trees. We then speak of a coppice or a copse or grove, and then we finally move into what we call is the forest. So we find ourselves in wood and then into groove and finally getting into forest. So there are many other ways just like this expressing an undefined numbers of most commonly animate object. For example, we can say a gaggle of geese, or we can say most importantly a school of fish. We can also say a swarm of bees, or we can say a pride of lions, and we can say similarly thoughts such as a brace of oxen and so on. So this is basically how, similar to the English language, the counting started. And the basic reason for showing this to you is that you will see that how mathematics evolved more as a language than as numbers and symbols and etc. So this actually shows a similarity, analogy between the counting of the head and toes by the aborigines and the hunters, similar to that of how we speak and gather things dual to 3, 4 or 5 in English language. So we now move on to something which we call dual, trial, or we can say 3 numbers, or sometimes it is told as trinal, and then into quadruple. So in many languages, nouns and pronouns, I would say, had or still have more than 2 forms. In some cases up to 5. For example, singular, a dual, as you can see here, a trial or trinal, a quadruple or quadruple, and it gets into plural. So trial and quadruple forms are today found in nearly exclusively in what is called an Austronesian language, which means it is spoken mainly in Australia, Polynesia and Melanesia. We will look into the language of Melanesia, and a typical example of dual and trial forms of personal pronouns are actually offered in what is called a Melanesian language. And Melanesian language is nothing but these languages which are spoken: Malay, which is in Indonesia, Javanese, which is in Java, Tagalog, which is in Madagascar, and Cebuano or Cebuano, which is spoken mostly in Philippines. Now, the Melanesian language, I would say the Melanesian archipelago, is basically a large group of islands on the southwestern Pacific Ocean. It basically includes islands like Fiji, New Guinea, and the Solomon Islands. Researchers have found that some Melanesian language has bases of binary 2 or base 4 system, where counting relies on grouping of 2 or 4 objects. This actually suggests that the development of numerical systems based on readily observable things in the environment like hands and fingers and so on. Now this person, Jules Dumont d'Urville, I'm sorry if I'm pronouncing the French word incorrectly, was basically a French explorer and a naval officer who explored the southwestern Pacific, Australia, New Zealand, Antarctica. He was a botanist, cartographer, and he gave the name of several seaweeds, plants, and shrubs. Now, why is he important? Because he is the first person actually to discover what is called the Melanesian archipelago. Now, I would sincerely apologize that if I am pronouncing these words incorrectly, because these are the dual or trial forms of pronouns offered in the language of the Melanesian archipelago. So you see, the first person is called Ainjak 1, Aijum Rao V2, Aijum Tai, and Aijam. For the second person, Ayak, and then is Aija Rao, then Aija Taij, and Aija U. I know it sounds funny, but that is what history and the document says so. Then we have got Ain, that is he or she, Arau, dual, this is the third person, trial, Ahtaij, and ARR as in plural. So this is actually the first person, second person, and third person. The importance of the Melanesian language or the Melanesian archipelago is that this actually is used in terms of counting. So if we trace back the genesis of counting, first what we find is the Austronesian language and the dual and the trial forms. As you can see, 1, then we have V, then we have the trial, and then we have the plural. Now there are many languages which we will see interestingly which contains this singular, dual, and the plural, but not many languages have got the trial. And among this, one of this is the Sanskrit language. So it has got a singular, for example, I can say singular aham, that is I, one person. It has got a dual, that is awam, we, 2 people, inclusive. Then we have got a plural, that is vayam, which is we, more than 2 people, inclusive. Don't take it on a literally sense, because there are a lot of grammars involved in it which I have just ignored, just to show you that Sanskrit do have the singular, dual, and plural form. So here is putra, son, singular, putro, 2 sons, and putra, which are sons more than 2. Similarly, we have hasta, that is one hand, hasto, which has got two hands, and plural hasta, which has got more than two hands. And you will be astonished to find out that also when I was learning the Arabic language, I find a remarkable similarity between the Sanskrit and the Arabic, because Arabic also have those three forms. Okay, so we move on to the next language, which is the classical Greeks, and they call is anthropos. So you can understand anthropology, etc. How does it crop up? Anthropo, dual, two men, and anthropoi as plural men. In Arabic, for one man we have got rajul, or we can call rajalun, that is for articulation. Then we have got rajalin, that is Arabic for dual two, and then we have got rijal, that is for plural men. So as I was telling you, see in the Sanskrit language, if you can go back few seconds in the video, you will see the same. You got aham, and then you got avam, then you have got vayam. So rajalun or rajal, rajul for singular, rajalin for dual, and rijal, that is for plural. In case of Greenlandic, that is very ethnic in terms of developing the genesis of calculation, you will also find this. So singular one man is called INUQ. I don't know how to pronounce it. It might be Ainuk or Inuk. Then we have got Ainuk. Then we have got Inuit, that is plural. Now, strangely enough, you will find that Hebrew also uses the dual form chiefly for paired body parts, for example, 2 ears, 2 feet, or objects like that. So you might be wondering that is this a language class? No, but as I told that mathematics is definitely a language. So the what I would say, the starting of the counting in terms of numbers, bodies, etc., all starts with a language. Now, incidentally, you will see modern English and its present old form. So the old English actually has got no dual forms. The middle English has got no dual forms, and the modern English also had got no dual forms. But history, if you trace it back, then you will find that both old English and Middle English had dual forms in the first and second persons of personal pronouns. And here is a table which will give you an understanding. So if I take the nominative first person, then the singular would be IC, ik, or whatever, I don't know the pronunciation, so it would be I. Then dual would be WIT, wit, V2, and then we have got V, that is the what we call V. Similarly, in genitive cases, you have got MIN, mine, in case, then we have got uncer, UNCER, again kind apologies if I'm making the pronunciation wrong, and URE, that is our, and so on. So the TH that you signed, that the underline, indicates actually something as then or either, something like that. So this actually shows that it is not that English language did not or lacks certain singular, dual, or plural forms. Yes, it used to have, but as history accounts that after the 13th century, all traces and all marks of the dual form in English are vanished, and they are eradicated, and they are vanished. Now, if we trace back the earliest symbols or forms of reckoning or counting the numbers were uncovered by archaeological excavations in the area of Middle East, dating from about 100 centuries before our time. So some of these findings suggest a form of counting where these things like markers, counters, tokens, and various other things, I mean to say in case of a barter system also, actually corresponded directly with things or goods that they represented. So these things actually are great symbols. I would say these are great clues for historians and mathematicians, because from these I would say from these systems, symbols for abstract numbers and quantities eventually develop. Now these abstract symbols applied to any and every object, but remember, symbols previously each represented a specific commodity. So this is, you can say, the concept of pure quantity, or mathematical concept of pure quantity was born. Now the concept and the idea and the question lies is that what actually those symbols, I mean to say the tokens and the markers, actually they represent. What the evolution history tells us. Number one, it tells that it shows a concrete representation. That means these markers, tokens and counters directly represented tangible items or units being counted. For example, a stone or a brick might represent a sheep or a flock or a bush of grain or something like that. Also, over time, as societies became more complex and trade expanded, these rose a need for more abstract system of counting that could represent quantities beyond what could be physically represented. So we can say gradual abstraction led to the development of symbols that could represent numerical quantities without direct reference to physical objects. Also, as societies developed systems of writing, these symbols of abstract quantities began to, I would say, take on a more standardized form. Instead of representing specific objects, they came to represent numerical values independent of the context that we are speaking about. Finally, yes, mathematical concept developed. So the development of symbols for abstract quantities were closely linked to the emergence of mathematical concepts such as addition, subtraction, and so on. And these symbols allowed for the multiplication and the calculation and manipulation of quantities in increasingly complex ways. So the relevance of these tokens, quantities, symbols, etc., which was discovered in the Middle East, etc., carried a concrete representation. It formed towards gradual abstraction. It was a symbolic representation and expanded on the mathematical concepts. Now we go back and find out where from the word actually number came in. So it actually, the Old English as number is rim, RIM, which also means part, and Middle English, I would say, got number or NOUMBRE via the Old French from Latin numerus, which means many or so on. The term number and numeral are generally, can be used interchangeably, but in some instances, finer distinctions or nuances are required. And as you see that we will follow this, number one, numbers which represented magnitude or position. Cardinal numbers, as you can see, 0, 1, 2, 3 or so on, allows us to count the objects or ideas to a given collection. Ordinal numbers, first, second, third, etc., state the position of individual objects. Integers used to denote 0 and positive and negative, etc. Then we come to the next part, which are the fractions. And fractions are basically used to represent a part or several equal parts, maybe 1/2, 2/3, and so on. Numerals are symbols or combinations of symbols which describe numbers, and digits are specific symbols used alone in combinations to denote numbers. Now these are, these are some important areas which we are defining, although it sounds very rudimentary and casual, but these are the things on which the genesis of the mathematics is built upon. Now we all know that numbers are interestingly also related to myths and symbols, and a lot of symbolism which comes across. So many numbers have mystic or mythical association. All things, for example, whether it is good or bad, is connected with this number 3. 5 is found particularly in the pentagram of mystics and soothsayers, and in the the pentacle of Solomon. The 7 arm of the Hebrew candelabrum and the 7 wonders of the world, although they are not always the same. And then we have what we call is the proverbial number 40. Now this 40 is actually more realistic, because even mathematical association attaches to the number 40, indicating many or too many. Just I have given an example of Ali Baba and his 40 thieves. Moses also, the children of Israel were foot slogging for about 40 years through the wilderness of the Sinai desert, and Moses definitely was away from his people for 40 days and 40 nights when he was given the 10 commandments on the Mount Sinai. Now these are, I know these are mythical tales, these are abstract things, nothing related to the science or mathematics. What it is actually shows is that these historical and religious and cultural influences have collectively contributed to the spreading of many superstition. For example, the number 13, which leads to the reputation that it is a symbol of bad luck. Now we will come to that. Why do we call this as number 13 to be unlucky? I mean to say, if we cannot just call, when history tells this number to be unlucky, there should be something, because if there is a smoke, there has to be some amount of fire inside it. So as you can see, that 13 is something which forebodes bad luck. So the first thing is that the Last Supper, which is one of the most famous origins of the superstition from Christianity. So it says that there were 13 individuals present at the Last Supper, including Jesus and his 12 disciples. Judas Iscariot, who betrayed Jesus, is often described as the 13th guest. So this association of the betrayal and the subsequent crucifixion of Jesus actually contributed to the belief that 13 is something unlucky. Now here is something interesting. The Norse mythology, there's a story about a banquet in Valhalla, the hall of the god Odin, and at this banquet 12 gods were invited, but Loki, the trickster god, crashed into the party as the 13th guest. His presence led to chaos and ultimately resulted in the death of one of the beloved gods, Baldur. So this myth also came to the negative connotations of the number 13. And you will see that in the Middle Ages, most importantly, the Knights of the Templar, where there was burning and all those fighting, etc. So that actually took place again on the Friday of the 13th. So overall, what we see is that these numbers actually are, you can say, they ushered a kind of a notion that 13 is a bad luck. It brings forward, ushers something which is very bad, etc. But I mean to say, this is just a notion. Do let me know if 13 is a good number or a lucky number or a bad number for you in the comment box. Now, what actually we get from this, mythical symbolism and understanding is that the most fundamental reason for counting likely actually stemmed from practical needs. So keeping track of possessions, days or cycles or seasons, calendars, whatever, would have been crucial for early humans. Also, you see the cognitive ability that counting developed at our inherent ability to recognize things. So the basic ability then evolved into more complex systems. Yes, there were cultural importance because numbers transcended more counting and became imbued with cultural significance. This reflects human attempts to understand the world around them, sometimes through numerology, symbolism, and whatsoever. Yes, it also evolved into symbols. So over time, symbols and systems for representing numbers emerged, allowing for more sophisticated calculations and record keeping. So overall, what we can say that the development of counting and numbers reflects both our practical needs as well as our desire to find meaning and order in the world. It is a kind of a testament to human ingenuity and our ability to develop abstract concepts from basic observations. However, there are certain fundamental questions that remains unanswered. For example, how different cultures discovered counting system. I mean to say, how the different cultures call this counting system, how Greek symbols evolved, how the Roman mathematics evolved, and how the English numbers came into being. I mean to say, the etymology, and how different languages actually built the numbers and what they call the numbers. These are 1, 2, 3, 4, 5 very fundamental questions that still remains unanswered in today's video. Hopefully we are going to cover these answers into the next video. So stay tuned until I come up with the next video on the genesis of mathematics. That's all for today's video. Thank you very much for watching. Please do subscribe to my channel Physics for Students and hit on the bell icon to get all the notifications. Here is my email ID and you can subscribe to my other channel General Relativity Explained, which is exclusive to Einstein's General Theory of Relativity. Further, you can follow me on my Facebook, LinkedIn, Instagram and Twitter account. Physics for Students will be soon back, and this Genesis for Mathematics will continue episode wise. And do let me know how did you like the first episode. Looking up and coming up with more videos on this topic and various other topics. But till then, goodbye.